Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Stretching by Koktuslav. And here are the rules. We need to divide the grid into 9 orthogonally connected 9-cell regions, and we need to place the digits 1 through 9 once in each row, every column, and every region. So this is typical chaos construction. And what is an orthogonally connected region? Well, it's a region where you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because to get from any cell in the region to any other cell in the region, you can just go through edges while staying within the region. This is not a valid region. These two cells, you can go to each other by going through edges while staying within the region. But to get to the other cells in the region, they have to go through a corner, or they have to exit the region by going through an edge, which is not allowed. So that's an example of how orthogonally connected regions work. In cells with arrows, the digit equals the number of cells in its own region, including itself, visible in the arrow directions. Sight is blocked by region borders or the edge of the grid. So in cells with arrows, the digit equals the number of cells in its own region, including itself, that is visible in the arrow directions. So if this were to be so say this was a valid region, this would see 2 cells in its region, this would see 2 cells in its region, and this would see 4 cells in the region. So if this were the valid region, this would have to be 2, this would be 2, and that would be 4, because it sees this cell and these cells. Let's use a different type of region here. Let's try this. 1, 2, 3, 4, 5, 6, 7, 8. Let's say this is the region. This would see only 2 cells because it's blocked by region borders from seeing other cells in the region. So this would be 2. This would be 3. Same reasoning, right? It sees these 3 cells, but then it's blocked by this border here, so it cannot see that cell, so this would be 3. This would see 3 cells also. So obviously that's not going to work. Okay, let's make it this way then. So this would then be, this would see 4, this would be 4. Oh, so we still have the same problem. Well, okay, let's make it here. Then this would be potentially a valid region, right? Because this would see 4 cells this way. This would see 3 cells here. It would not see that cell because it's blocked by a region border. This would only see 2 cells in this direction. And that's an example of how these arrows work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we have an interesting... So let's draw the borders around the entire grid. We have an interesting thing going on in row 1. Every digit in the row counts the number of digits that are going to be in its column. And it has to be the digits 1 through 9. So we definitely have a 9 somewhere on this board, on this line, and a 1. We have all the digits from 1 through 9 in this line. So that means you're going to see 9, you're going to see 8, you're going to see 7, you're going to see 6, you're going to see 5, 4, 3, and 2, and 1. And I think it has to be in that order somewhere, right? Well, the 9 cannot be here, because then you'd have multiple cells here be 1. which is because you'd only see one cell in its region. And if you have 9 here, you can't have 8 or 7 or 6. Well, that's not necessarily true. Okay, where can 9 be? 9 cannot be here because then all of these cells would be 1. 9 could be here. That's possible. 9 cannot be here because this cell sees all of these. But if this is 9, that cuts this off, and this would have to be a region by itself, but then that would also see 9 cells in that direction. So this cannot be 9 either. This can't be 9 this way because this cell sees the same amount going in that direction. Same with this one. This one sees the same amount. If it's 9 going this way, we'd have 1 and 1 here. These would see the same amount. This would see the same amount. So 9 in, and you can't have 9 here because you have the same problem as 9 being there, right? If 9 is here, this forms of one region then because it's 9 cells, but then this cell would also have to say 9 cells in its region. So none of these can be 9, which means 9 is here. So this is 9 here. We'll mark that as blue. I guess we could make it as orange, though. Make it orange. So that's done as a region. Where about... Okay, so we have 8. If we have 8, we can't have 8 here. If 8 is here, it can't block off this region, these cells from a region here. So it would have to go that way, but then this would have to be a 9-cell region, and therefore there would be 9 there. So this can't be 8. This potentially could be 8. Where can 8 be also? 8 cannot be here because we'd have to have these cells. Only 2 of them could be non-1, right? You could only have one cell extending out that way. Okay, so... Right, if you had 8 going this way, the problem is you only have one cell left in the region. So then one of these 3 would have to be essentially a... One could be a 2, but then the other 2 would have to be 1, which would have a repeat in the column, so that's not allowed. We can't have a green here, an 8 here, for the same reason we can't have an 8 here, right? It either blocks off these cells here from forming a full region, or we go this way, and then this has to be a 9-cell region, but then we'd have to have a 9 there if that's the case. So 8 can be any of these. Can be any of these 4 or here. This has the same problem of 8 as this cell, as this column here, because if we have 8 here, well, I guess he could have 1 going there. That doesn't... Okay, so that's not exactly the... Oh. No, it doesn't have quite the same problem as this. It's a slightly different problem. So if we have 8 here, only both of these see 8 cells, so they have to be 8 or 9, but you can only have... If they both see... You can only have one more cell going this way. So then one of them's 9, the other one has to be 8, which is not allowed. So this cannot be 8 either. This could be 8 if you have one going that way or one going that way. So that's possible. 8 also cannot be here because of the same reasoning. Well, not completely, but basically if this is 8, and this has to be 8 guaranteed also. So these cannot ever be in the same region. Oh. So because... Okay, so these two can never be in the same region, because if they are, they would see the same amount of cells. So then this is 1 through 4 here, guaranteed. At most. This could potentially be 8 if this is 9. So that's possible there. So 8 could be here, 8 could be here. And 8 can be here. Okay. So we definitely have a region border here. Because these can't be part of the same region. We have a region border between this and this. So this then always sees one cell. So that's 1. Which means this can never be 1, so this is always going to be the same region. This cannot just see 2 cells, because if it's 2, then it's blocked this. Well, I guess it could. No, but this is a separate region. I mean, I guess this could be 1. And then go this way. No. So this can't be 1. If this is 1, that forces this to be part of this region, because it can't be part of this region, because this region already has a 1. So, if we tried going this way, the problem... if this were 1, this would go this way, and then it would have to go that way, and then this would have to be 1, because this would be a different region than it, right? So this can't be 1 either, which means this is part of the same region. So let's make this green, and we'll make this light. So green has to go at least that way, so this is at least 3. This has to go at least once this way. Light has to go at least once this way to be at least 2. This has to be at least 2. What else do we have? If we have 5 here, I guess that's possible. 1, 2, 3, 4, 5, 6, 7, 8. That is possible. So this is at least 2. It's 2 or 3 here, guaranteed. So then these 2 are part... Okay, so this sees 2 cells. So this has to be 2 here. This must be 3 cells here. Because this can't be 2. So this is 3 in the same region there. This cannot be 1. I guess it could... Well, both of these cannot be 1, essentially. If this were 1, that has to be in the same region as that, which would not be in the same region as that. So this cannot be 1. This has to be part of this region here. So it cannot be 8 there, because we already have 2 cells here. This can't see 8 cells that way. So this sees 3. This must be not 2, 3, or 1. So this is at least 4. So that means this is part of that region. Then this must be 2. This must be at least 4. It has to see more than 1 cell here, because it has to be different from this digit. So this is going to be at least 1 greater than that. So this is boundary here. This is 3, 4, 5, 6. Cannot be 6. It could be 6, right? You can see 3 that way. We have 1, 2, 3, 4. So this is boundary here. This, if it's part of the region, doesn't work. Right? It can't see 3 or 4. If it's part of, this is part of the region, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 cells. So this would be done as a region. This would then only see 3 cells. So this cannot be part of that region. It must be part of a new region, which means this is a 1 here. So we have boundary that way. This could see up to 8. We don't know. It cannot be 8 anymore, because if it's 8, this only sees one cell here, and because this would be a full 9-cell region. So this cannot be 8, which means 8 has to be here. So that's done as a region. So it sees 8 here. We don't know which of these. So this is a boundary here. So this is, we're going to mark this as blue. This sees 1. This must see more than 3, more than 2. This sees 4 or 5. And this sees 5 or 6. So this is a boundary here. This is at least 3. This is cannot be 1 or 3, and it can see at most 2 here, so this must be 2. So this is 2, which means this is part of the same region. This can't see just 1, so this is part of the same region also. How does this work? This is going to see combined 8 digits at most. So you're guaranteed this has to have a 3. And you have to have 4 or 5 with it. So this becomes 3, 4, or 5 here. Which means this can't be 3, 4, 5. It's 6. So therefore that sees 6 cells. This cannot see just 1 or 2. It has to be 3. And that's done as a region. Because that's 9 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that sees 3 cells. This can only be part of light. So this sees 4 cells here. That makes this 5. This cannot be 4. This is 3 and 5 as a pair, which forces this to be 7. Dark has to then, 7 goes this way. So dark has to go that. So that's 8. Then we have boundary there. Blue has to go this way. Boundary there. We know this is boundary here. So this sees 2. So we see 5 here. This sees 6, this sees 2, this sees 4, this sees 1. One of these sees 3, one of these sees 5, this sees 7, 8, and 9. So this sees 2 here. And that's done as a region. This sees at least 7, so it has to be 8 or 9, which means this is pink. This is done as a region, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that's done as a region. This sees 2 that way. This sees 5. That sees 3. This sees either 3 and 1, which is 4, or 5 and 1, which is 6. Remaining digits in the light region. We have 1, 6, 7, 8, 9. No 1 here, no 1 here, no 1 here. So 1 is one of these 2. Okay. If this goes medium, medium here, the problem with that is we have 2 cells which have to have a region. And they both cannot belong to pink. Only one of them can belong to pink because we have 8 cells in the pink region. Therefore, this cannot be medium, medium here. This must be medium, medium here. So then this is 5, that's 6, this is 3. This is done as a region. No 6 here. Remaining digits of the medium region then are 4, 7, 8, 9. Okay, remaining digits of the green region are 4, 5, 7, 8, 9. No 5 here, no 4, 5 there. Okay, this cell sees at most 6 this way, and it cannot be 1 or 3, so it's 2, 4, 5, or 6 there. This cell could see up to 9. We don't know. Okay. This sees at least 3. So we have 3, 4, 7, 8, 9. It cannot be 9. Remaining digits of... Okay, so whatever digit is here is here. So remaining digits of dark are 1, 3, 4, 5, 6, 7, 9. Obviously no 7 there. No 1, 3, 6 here. No 5 here. No 3 there. This is then the same as that digit. 1, 3, 4, 5, 6, 9. Okay, remaining digits of row 2 are 4, 5, 7, 8, 9. No 9 here, no 7 here. Okay. This sees at most 6 cells. So it could be 1, 4, 5, or 6 there. This sees at most 8 cells. Because it could be part of blue, or it could be part of pink. But we don't know which one. Actually, it can't be part of pink. It could be part of blue. But even then, that can't see 8 cells then. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would see 7 cells there. So this is at most 7. Obviously, it could be a different region, which would then be 7 also. So this is at most 7, 1, 3, 4, or 7. And it has to orthogonally connect with one of its regions, so this can't be 1. What are the remaining digits then in column 6? It has to be 1 and 2. So this is a 1, 2 pair here. Interesting. One of these is going to be a 3. Interesting. So if this is 3 this way, it has to go up, which means that's part of the same region. If this is 3, it could do something like that. It could do something like that. It could do even something like this. That's not helpful. This cannot be 1. But it could be a lot of... It cannot be pink. 1, 2, 3, 4, 5, 6, 7, 8. It could see... It can't see 9. So this can't see 9. This is 2 through 8 here. This is 1 through 5. Cannot be 1, 2, or 3. So this is 4 or 5 here. Which means this is all part of the same region. So this cannot be 7 or 8. It's 3 or 4. Interesting. This cannot be 4. If this is 4, that would force this to be 5. And this would then see 5 cells here. This could only see 3 if that's the case. So this can't be 4. This is guaranteed to be 3, which means this can't be 3 here. That means we have a boundary here. So this must be blue going that way. This obviously can't be 3, so this can't be 3 there. This sees 4 or 7. Can it see? It could see 7, going like that. If it sees 4 even, it's not part of pink, so this is guaranteed to be part of blue, which means this can't see 1 cell. So this cannot just see 4 cells then. Because if this sees 4 cells, this would see 5, and that would be... So this has to be 7. So this sees the remaining digits in this region. And this is blue, so therefore this can't be... This can only be red left, which makes that C5, which eliminates 5 in the rest of the column. Whereas 5 in the green region, then it must be here. So that's 5, which means this can't be 5 here. There's no 5 there. This sees 7 cells, so it sees not these two. It sees the remaining cells here. It cannot be the full 6 here because then red doesn't extend as a region. So this cannot see 6. This must then be able to see 7, so it has to be that. So this is done as a region. That means red has to go this way. So this is done as a region. Pink has to go this way. So this is pink, and these must be yellow. So these could be yellow, and one of these two is red. So this sees 4 cells. So this is 4. This sees 9 cells, all in the region, so that's 9, which eliminates 9 here. No 9 here, so this can't be 9. This sees 5 cells here, so this is 5, which eliminates 5 here and 5 here. 7 eliminates 7 in the column, so this is 4, 8, 9 as a triplet, which eliminates 4, 8, 9 in the rest of the box, or the region, so this can't be 4, 8, 9, it's 7, which eliminates 7 in the rest of the row. This sees 5, this sees 1, 2, 3, 4, 5 at least, and then it could be 6 or 5 or 6 here. Okay. And the rest we fill in with normal Sudoku. 3 has to be in the red region, and 3 cannot be here, here, or here. Therefore, this must be 3 here, which means this can't be red. That's yellow. So we now have all the regions, and this must be 3. This sees 6 cells, so this is 6, which eliminates 6 here. We have a 7, 8, 9 triplet in the light region, so that eliminates 7, 8, 9 in the rest of the light region. So this is 1, 6 as a pair, which eliminates 1, 6 in the rest of the row. 4 eliminates 4 here. We have remaining digits in the red region. We have 1, 2, 4, 6, 7, 8, and 9. This can't be 1 or 2. This can't be 2 here or here. This can't be 4, no 4 or 6, no 2 here. So 2 in the red region has to be one of these 2 digits. 9 here. Okay, so all these arrows are done. Let's just double check. This sees 6 cells here. 1, 2, 3. This sees 5 cells here, 3 cells here, 2 cells here, 3, 4, 5. 1, 3, 5, 2, 6. This is 7, 8, 2, 9. And this is 9. 6 cells here. 4 cells here. 5 cells here. 7 here. And 3 that way. So all the arrows are done. It's just basically normal irregular Sudoku. Okay, we know one of these is 7. That eliminates 7 in the rest of the row. We have a 4, 8, 9 triplet in row 3, which eliminates 4, 8, 9 in the rest of the row. Yeah, 7 can't be here because of 7 in the row. So this cannot, that means the remaining digits is 1, 3, and 6 in row 3. No 4 here. Remaining digits of column 2, we have 1, 4, 6, 7, 8, 9. No 4 or 6 here because of 4 or 6 in the yellow region. No 7 here because of 7 in the blue region. No 7 here because of 7 in the row. No 6 here because of 6 in the column. Okay. No 7 here. Remaining digits in column 5 are 1, 4, 6, 7, 8, 9. No 4 or 6 here. No 4 or 6 here. No 4 or 6 here because of 6 in the yellow region. This eliminates 6 here because of 6 in the row. Wait, how did I get that? That's wrong. It's 1, 4, 6, 8, 9. There we go. So no 4, 6, no 4, 6, no 4, 6 because of the yellow region. We have a 1, 8, 9 triplet now in column 5 and in the yellow region. This can't be 1, 8, or 9. It's 7. This can't be 1, 8, or 9, or 6, so that forces this to be 4. That leaves that as a 6 there, which eliminates 6 in the red region. This 6 eliminates 6 here, so this is the same digit as that. This can't be 6. 4 eliminates 4 in the pink region. The remaining digits in the yellow region then are 2, 3, and 5. 3 cannot be either of these, so 3 has to be here. 5 can't be here because of 5 in the column, so that's 2, which makes that 5. 2 eliminates 2 here, so it's 1 and 2. 4 and 7 and 9 eliminate 4, 7, 9 here. That's 8, which eliminates 8 in the rest of the green region and in column 1. So remaining digits in row 6 are 3 and 5. This can't be 3 or 5 because of 3 or 5 in the row. Remaining digits of column 4 are 2, 7, 8, 9. And this can't be 2 or 7. We have an 8, 9 pair in column 4, which eliminates 8 and 9 in the rest of the column. This can't be 8, 9, it's 7. This can't be 7, 8, or 9, it's 2. Which eliminates 2 here. 7 eliminates 7 here. Okay. Remaining digits of column 3 are 1, 6, 7, 8, 9. No 7 here because of 7 in the row. Okay. Remaining digits of the blue region, we have 1, 4, 6, 8, 9. There's no 9 here because of 9 in the column. Where is 9 in the blue region? It must be one of these 3 digits, which eliminates 9 here. So that's 4, which eliminates 4 in the rest of the column and region and row. So this can't be 4. This is 1, which matches 1 here, because then 1 can't be any of these digits. 1 can't be here because of 1 in the pink region. That eliminates 1 from being here. This can't be 1. This is 6, 8, 9 as a triplet, which eliminates 6, 8, 9 in the rest of the blue region. This can't be 6 or 8. It's 4. 1 eliminates 1 here. We have a 7, 8, 9 triplet in the red region, which eliminates 7, 8, 9 in the rest of the region. This can't be 7, 8, 9. It's 1. This can't be 7 because of 7 in the column. 1 eliminates 1 here. So that's 6, which makes that 1. 6 eliminates 6 here. Where is 6 in the blue region? It must be here. We have an 8, 9 pair in column 2, which eliminates 8 and 9 in the rest of the column. This can't be 8 or 9. It's 4. Which eliminates 4 here. Where is 4 then in column 6? It must be here. 1 eliminates 1 here, so this is 8 and 9. No 3 or 4 here because of 3 or 4 in the row. Remaining digits in... This has to be 7, 8, or 9. But it cannot be 9 because of 9 in the column. So where's 9 in row 9? It must be one of these two cells, which eliminates 9 from the rest of the region. This can't be 9. It's 7, which makes this 9, which makes that 7. 7 obviously eliminates 7 here. 9 eliminates 9 here, so that's 8, which means this can't be 8. This can't be 8. 1 eliminates 1 here, so it's 9, which makes this 1. No 7 or 9 here. Where... Remaining digits of row 7 are 4, 6, and 8. Okay. This cannot be 4 because of 4 in the column. This is fine. Remaining digit in row 8 is a 3. So that's 3, which eliminates 3 here. This is a 3, 6 pair, which eliminates 3 and 6 in the rest of the row. So this can't be 3 or 6, it's 1. 3 eliminates 3 here, so it's 5 and 3, which eliminates 3 here, so it's 6 and 3 there. 6 eliminates 6 here, so it's 4. No 4 here. 4 eliminates 4 there. Where's 4 in row 2? It must be here. So that's 4. This can't be 6 anymore because of 6 in the column. 9 here eliminates 9 there. 7 eliminates 7 here, so this is 9, which makes this 5, which makes that 7. 5 eliminates 5 here, so that's 8, which makes this 9, which makes that 8, which makes that 9, which makes that 8. We have 2 and 5 remaining in row 4. This can't be 5 because of 5 in the column, so that's 2, which makes that 5. This can't be 2 anymore, so that's 2. And 6 there, which makes this 8 and 6. 8 eliminates 8 here, so it's 7. 8 eliminates 8 here, so it's 9, 8, which makes this 9 and 8. And that's the solution. Very, very, very cool use of these arrows. There was a lot of interesting logic built into these arrows that I didn't see upon initial glance. So it was very, very interesting for those. Particularly where these digits could be, right? I did identify immediately that that this was very important, but I didn't see how these interacted necessarily, which was interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.